All right, guys, composite functions. So we have a lesson today that's going to set us up for what we're doing in class over the next few days. But first, I want to review something from last school year and from Algebra 2. So let's say that we have a function, or we have two functions. We have the square root of x, and we have 2x plus 1. And we're asked to find f of g of x. And so what this says is whatever function's inside, we're going to take the entire thing and we're going to plug it into the outside function wherever there's an x. And so we're going to take that 2x plus 1 and we're going to plug it in right here for x. So if we do that, it just says the square root, and then where there was an x, now it's 2x plus 1. All right, so that was last year what we did. This year we're actually trying to do this, but kind of in reverse. Okay, so we're trying to identify anytime that there's an inside function and an outside function. All right, so we're going to look at some problems. And this is one we just did. To kind of help us get started here, we're going to do it just like this is the first time we've seen it. So I'm telling us a function. I don't tell us that it's composite, okay? But I'm giving us a function, and it's the square root of 2x plus 1. Now, if x is ever inside of something and it's not by itself, this is what we're going to have to think through. Is there an inside? Is there an outside? And so our inside function is just whatever's in the square root right here. So 2x plus 1. Now, the outside function is the square root. I'm going to call it the square root of something. And for now, we're going to call that something just x. Okay, and you guys will get to in the next lesson why I'm just calling it something. But the square root of x. All right, so this inside function was plugged into that x for the outside function. All right, let's look at a trig function here. So inside, wherever x is it by itself? No, there's a 2 here. So the inside is 2x. And the outside function is the sign of something. And we are just going to call that function x for now. Okay, the sign of something or the sign of x. And you can see with both of these, if I took the inside function and I plugged it in for x, we're back at the original problem. All right, a few more. Again, inside, outside. So here x is in the exponent, okay, but it's not by itself. So the inside is x plus 4. It doesn't always have parentheses, but you could. I mean, you could put parentheses around that. But usually we do exponents without parentheses. All right, so the inside is the entire exponent. The outside function is e to the something, or again, just e to the x. All right, and again, you can see if I took x plus 4 and I plugged it in for x, we're right back here. All right, j of x. So this notation is a little bit misleading whenever it says sine squared of x. A better way to write it is like this, sine of x all being squared, like that. So whenever you have an exponent on a trig function, it's probably better to write it like this right here. So inside and outside, inside the parentheses is not just x, it's sine of x, and so that's our inside function. The outside function is something squared, and again, we're just going to call it x squared, but something is being squared. All right, and again, if I plugged in sine of x for this x, we're right here now. All right, last one. This is going to be a super short video, but we need to probably spend a full class period or close to it practicing this to set us up for our next part here. Now, this one's a little more difficult because it has an outside, it has an inside, but it also has a middle part. We're going to see in a second. So I'm going to write this. Anytime we've got an exponent on a trig function, I want to put parentheses around the trig function. So we're going to have cosine of x plus 4. And all of it is being cubed. All right, cosine of x plus 4. All of it's being cubed because the cube was on the cosine. All right, so here there's 3 layers to this. So that's what we're going to label it as outside, inside, and middle. Let's go to the part that's inside both sets of parentheses. That's the x plus 4. All right, and so x plus 4 is our inside function. Then we go to the next part that's inside the parentheses, And so that's our cosine of something is our middle function, cosine of something. We're going to call it cosine of x. And then our outside function is something being cubed, which we'll call x cubed. All right, you can kind of go up the list here and just double check this. So if I plugged x plus 4 in for x, then it says the cosine of x plus 4. And if I plugged cosine of x plus 4 in for that x, we're right back here. All right, so that's how we determine if there's an outside, inside, and middle. And again, not every function will have this. So if it's just like the square root of x, right? We've worked with that in the past. We know its derivative. We have not worked with something like the square root of 2x, right? And so that's why we're doing this whole process where we identify the outside and the inside, or potentially the middle as well if there is. All right, so that's what we're going to do in class. Stay flawless.